I've been in networking for over a decade and decided to make some content to try to help others understand this industry. So, we looked at how data is sent between two endpoints that are directly connected together. So, now let's see what happens if we connect a switch between them. So, in this example, the PCs are set up the same way as before, where PC A has an IP address of 1.1.1.1/24 and a MAC address of all A's. PCB has an IP address of 1.1.1.2/24 and a MAC address of all Bs. So a switch operates at layer 2 of the OSI model, the data link layer. And so we have to physically connect the devices to the switch. So we're going to connect PCA to port 1 and PCB to port 2. These connections are part of layer 1, the physical layer. The layer 1 has to match between PCA and the switch, and it also has to match between PCB and the switch. But we could use different types of connections between PCA and PCB because the switch in between, that's where they're actually directly connected at layer 1. So A and B, PCA could be on copper and PCB could be fiber. That doesn't matter because they aren't directly connected at layer 1. The switch is in between there. And as long as the switch can handle a copper cable for the connection from PCA and a fiber connection from PCB, there's no issues there. So just another illustration of how these layers kind of operate independently. So once again, we've got where PCA wants to send a message to PCB. So there's our message up there. And just like before, PCA gets the segment from layer 4, which is the transport layer, and it applies the layer 3 header. This header contains the source and destination IP addresses. So since PCA is sending this traffic, it's going to have a source IP of 1.1.1.1. It's being sent to PCB, so that's going to have a destination IP address of 1.1.1.2. From there, it gets handed down to layer 2, the data link layer, and then it gets another header added at layer 2. So here we have a source MAC address of all A's because that's the MAC address of PCA, and a destination MAC address of all B's because that's the MAC address of PCB. So now PCA is ready to convert the frame into electrical pulses and send it across the cable to the switch. So now the switch converts the signal into bits, and it inspects the layer 2 header. It sees that the layer 2 destination is a MAC address of all Bs. The switch does not have that MAC address, so it knows it is not the layer 2 destination, but it needs to figure out where to send the frame. So in order to do this, there's a table that the switch has to reference that has a mapping of MAC addresses to interfaces or ports. That is called the MAC address table. So in this example, the switch would have two entries in it. We have PCA that's connected off of port 1, and that has a MAC address of all A's. So there's an entry there. And then there's another entry for PCB. So there's a MAC address of all B's is connected off of port 2. So the switch knows that the frame has a layer 2 destination MAC address of all B's. It looks in the MAC address table, sees that that MAC address is connected off of port 2. So the switch sends the frame on its way out port 2 towards PCB. Then when PCB receives it, converts the signal at layer 1 back into the bits, looks at the destination MAC address, sees that it's a MAC address of all B's, that is its own MAC address, so it knows it's reached its layer 2 destination. And so it can take off that header, and then it looks at the layer 3 header and sees that it has a destination IP address of 1.1.1.2, which happens to be PCB's IP address. So it can then take that header off, and then it's left with the original message. So all that's very similar, but let's go back and look at the MAC address table because there's a couple important things to mention about that. So we picked up this example with the MAC address table already having two entries in it. And some people may be wondering how those entries even got into the MAC address table to begin with. And also, well, what happens if the MAC address isn't found in the MAC address table? What does the switch do? So those are fantastic questions, and let's look at both of those situations. So When the frame came in from PCA on port 1 of the switch looks at the layer 2 header. We talked about it looks at that to find the destination that it needs to send the traffic to, but it also looks at the source. So when the switch saw that, it sees that the source MAC address of this frame was all A's, and it came in on port 1, so it can put that into the MAC address table. So the MAC address table is populated based off of ingress traffic, meaning as frames are received inbound on the port, the switch looks at the source MAC address and puts that MAC address, maps that to the interface where it received the frame. Another important part of this is that the MAC address table has an aging timer. So it's common for the aging timer to be 5 minutes. It can be configurable on most devices, but 5 minutes is kind of typical. So if the MAC address already exists in the MAC address table when the switch receives that frame inbound on port 1, it doesn't have to add that MAC address entry to the table because it's already there, but it will refresh or reset that MAC aging timer so that that entry doesn't get removed until that timer expires again. So that's how the information stays fresh in the MAC address table. Now, if the source MAC address is in the table, but it's assigned to a different interface, that's another situation altogether. So here, let's say we get that frame in on port 1. The switch looks in its MAC address table, sees the MAC address of all A's is mapped to port 3, but it received this on port 1. What the switch will do is actually update that entry and say, no, actually, this MAC address is on port 1. Now, if you see that happening a lot, it is an indication of that there's other issues in the network or could be other issues in the network. We're not going to dive into that of different layer 2 loops and things, but just know that if the MAC address is mapped to a different interface, then the switch will update that entry when it receives that frame inbound. So the other thing about this is what happens if the destination MAC address isn't in the MAC address table? Like, what does the switch do? So in this situation, the switch will take that frame and it will duplicate it and send it out all of its interfaces that are active except for the interface that it received that frame on. And this behavior is called flooding. So flooding is not the same as broadcasting. Broadcasting has specific addresses that it uses. In this situation, the switch isn't changing any of the layer 2 or layer 3 addresses. All it is doing is just duplicating it and sending it out all the interfaces. And the goal here is if that destination MAC address is somewhere connected to this switch, then it'll get to its destination. On the other hand, is if that destination ends up having to send a reply back, then what will happen is the switch will see that frame come in. It'll inspect that layer 2 header. It'll see that that source MAC address is on the interface where it received the frame. And so it can add that to the table. So in this situation, if PCB got that frame and had to reply back to PCA, PCB is going to send a frame towards the switch on port 2. The switch will look at the header of that frame, see that the source MAC address of all B's came in on port 2, and then it adds that to its MAC address table. So all of these are populated dynamically. Now, if an endpoint isn't replying to these frames, you could have a situation where all the traffic is just one way. And if the switch doesn't have the MAC address in its MAC address table, it's going to constantly just be flooding those frames out all ports. That really increases the amount of traffic on the network. So another option, instead of using dynamic MAC addresses in the MAC address table, is you can statically assign MAC addresses there as well. So you can kind of tell the switch and pin a MAC address to a specific interface, and it will always send traffic for that MAC address out that interface based off the MAC address table.